Hello. Today I want to show you a chatbot application built using Gradio on the front end that uses Cortex Analyst in Snowflake to convert natural language to analytical queries against some revenue data that's hosted in a table. So here's the application. We can start with finding out what are some of the types of queries that are supported. And so here's some examples. So we can find out on which day of the month the lowest revenue occurs. Let's go ahead and try that example. And Analyst returns the following tabular result based on the data that we have. And the cool part is that it actually translated our question into SQL. So it interpreted our question and it actually generated the following SQL statement, which it executed in Snowflake to get the result. And we can try an additional question. For example, what is the lowest revenue over this period? And again, it will convert our natural language query into SQL, execute it, and return the result. And there we go. Now let's take a look at how this was built. Backing the application, we have a container running in Snowpark Container Services with the Gradio application, which is written in Python. One interesting thing to notice here is that the service is running as the container user role. That's the role that the service was created with, and that's the role that the code is running with by default. On the other hand, here's the data that is being accessed by the chatbot. We'll notice we have a few tables in this database: daily revenue, products, regions, and based on the privileges we see here, you notice that it's actually the Cortex user role that has the ownership of this database, and the container user role that we noticed in the service does not actually have privileges to access this database. So how come our app works? Well, our app is utilizing a new feature called Caller's Rights in Snowpark Container Services. Let's take a look how that was implemented. This is how we created our service. And so again, just to emphasize, we're using the service user role. That's the role in which the service would normally run. However, we took some additional steps to allow the service to act on behalf of the user, or to inherit the rights or privileges of the user that's accessing the chatbot through HTTP. And the way we did that is by running the following set of grant caller statements. And you'll notice here, these are not regular grant statements, meaning we're not giving the role direct privileges to that database. We're merely saying that when a user is calling the service that has this privilege, then the service is also allowed to assume that privilege. And you notice this is secure by default, so we have to do this for every single privilege that we want the service to be able to use. Another change we had to make to our service code, you may have spotted it here in the beginning. We have to add this capability section that sets execute as caller true. This is what instructs the SPCS infrastructure that this service supports caller's rights. And the last piece is, if we go into the implementation here in the Python code, we'll notice that when we invoke Snowflake, we construct the HTTP request, and we use a special authorization header here. Normally, when you're calling from SPCS, you would use the login token, which is just available on disk in the container. However, in this case, to enable caller's rights, we're concatenating that with the ingress user token. And the combination of those two is what enables the service to act on behalf of the user. And the ingress user token is available as a header on incoming HTTP requests. So all users accessing the service through the ingress path, through its public URL, will receive this ingress token. And you'll notice here I'm using a middleware approach to actually strip that token from the request and make it available to my service. So that's it. This is how you use caller's rights to enable a service to act on behalf of the calling user. Thank you very much.